Welcome to another one of our special Scientia lectures. And today we're happy to have Dex Euromat, also known as Dominik Undak. Dex is a veteran of Second Life since 2008. He's a software engineer. He was also part of the Academia Electronica, which was officially part of the Institute of Philosophy of Jagiellonian University in Cracow. He was involved in many other educational and outreach venues and situations, including the Atlantis language learning community, and sharing knowledge about Poland in Virtual Worlds Education Consortium events, speaking with in Polish. He was involved in Community Virtual Library for a long time. And he also had built his own project, a Poland History House, with about history, inventions, and inventors of Poland, some of which you'll hear about today, about one of the crucial developments that helped end World War II. So as usual, please ask questions in chat, preface them with question in capital letters and then the question itself, and he will be the only one using the voice. So without further ado, Dex, it's all yours.
Thank you, George, for the introduction. Welcome, everyone. This is one of the lectures I've been doing, and today is the unbreakable code of World War II, which is history of cracking the Enigma machine. Today's slides are also available at Google Slides, so if you if you don't have the time now, you can also check that there. Or if you have problems with SL, you can also check that presentation there. So first about me, that's I am from Polish. I was born and I'm still living in Poland. I graduated as a Master of Engineering from the Department of Non-Ferrous Metals of IGH Science and Technology University of Cracow. Currently working as a software manual tester. I first joined Second Life in 2008, and this account is from 2010. Over the years, I have participated, as George said, in the following projects: Academia Electronica, Atlantis Language Learning Community, Community Virtual Library, Virtual Worlds Education Consortium, and also have my own project where you can get overview of Polish history and what we've invented. What you will know after this presentation: Enigma Machine history, why math approach was better than linguistic in deciphering the code, who was the original code breakers, how collected info helped Bletchley Park team, and were there any truth in the movies Enigma and The Imitation Game. First, we need to answer the question, what is Enigma? By dictionary, it would be an unknown resolution for a very complicated conundrum. But for us, the definition is a German encryption machine used by their military during World War II. However, that definition is not quite accurate. Better one is this: an electromechanical device used to encrypt and decrypt messages, created around 1920 by a German engineer to help fight industrial espionage. Later adapted by the German military for their communication purposes, continuously developed till end of World War II in 1945. As stated in extended definition, Enigma was not strictly a military device. We are in 1918. The Great War, World War I, just ended. Countries in Europe start to rebuild their economies with the help of Industrial Revolution inventions, and Germany suffers the most after the Warsaw Pact. However, some companies would like to get the blueprints and know-how faster than others, and they start spying on others to get this quicker. So these companies decided to encode blueprints and messages, but there was a problem. On the market there were already some known codes, and the cost of hiring staff to encrypt messages was high. Another issue was trust, that hired specialists would not sell the information elsewhere. Engineers around the world were struggling to make an easy-to-use device that helps with encryption and make the issue less costly. First that succeeded was Arthur Scherbius, German engineer. You can see one of the later versions of his invention in the picture. As mentioned, engineers struggled because they had to choose between two conceptions first: to automate existing codes with static circuit device, or make a device with alternating circuit and develop a new code. Scherbius chose the second option, as the first would be too easy to construct, but also too easy to decrypt and copy. His machine required just 4 main components: a battery to make the device portable, mechanical input, a typewriter, electromechanical scrambler with alternating circuits, and electrical output. The device was a great success and many versions were developed. Therefore, we will focus here on those adopted by German military, especially by naval forces, Kriegsmarine. However, it is worth noting that most complex versions of Enigma were used by the German intelligence. Some of those machines could have at least 16-step scrambler units with their own printers, punch tape for telegraphs or letters. Military adopted following versions of Enigma: A, B, C, D, M3, M4. But to better understand the difference between them, let's have a look on how it works. On Figure 1, you can see general placing of each Enigma machine components in the casing. The main scrambling unit is inside the red block. We have battery pack with 3 settings: on, off, outside power. Enigma was meant to be used with batteries. However, for these placed in stations, the extra cord for plugging the device to the electrical grid was supplied. Next to it, we have the main scrambling unit that consists of input-output disk, static with its own wiring, scrambling rotors, each with different wiring, that advances each time, reflector disk, which bounces the signal back through rotors. Below that we have the output bulbs section, which will show the scrambler output letter. Input typewriter, usually in QWERTZ keyboard, but some Enigma machines have alphabetical layout. Finally, the plug board, another step in scrambling that may change the input once or twice depending on the connected pair. The battery is connected to two ends, the typewriter and output bulbs, and the circuit is disconnected until the key is pressed. Once the key is pressed, the circuit closes, but the path will be different each time, and its route can go through at least 3 steps. I will tell you why in a few minutes, but essentially it can go via plugboard, I/O disk, rotors, reflector, rotors, I/O disk, plugboard to output bulb. Each rotor has similar construction, which consists of 26 brass flat connectors on one side, 26 brass cones connectors with springs on the other side, movable letter or number ring with a notch, drive gear for advancing fingers, index gear for manual adjustments. Indicator for first connectors, 26 one-way paired connection wiring like A to K. Reflectors on the other hand have 13 pairs of letters, usually in one-state rotation in the casing. While the machine casing already had a preloaded I/O disk and reflector, the rotors were supplied in another box. You might ask why. The answer is simple: security. In each scenario, the enemy would need months, even years, to build a functioning replica of Enigma with just one part of the machine. First Enigma machine was taken into military in 1926. In early military usage, each Enigma was using 3 of 3 rotors sets with different configurations. In 1944, Kriegsmarine adopted version C with 3 of 5 rotors set. In 1948, M3 for Kriegsmarine was given 3 of 7 rotors sets. World Military adopted early Kriegsmarine 3 of 5, and in next years updated to 3 of 8 rotor sets. M4 sets were similar to M3, but they can consist of 7 or even 10 rotors, as the fourth one was chosen from 2 possibilities. It is worth mentioning here that German engineers were working on a rotor with alternating wiring in late 1944. Fortunately, the lack of resources at the end of the war stopped that research. On the left side of the presentation you can see Enigma rotor's picture and a sort of recreation of it for better understanding. Now the answer for the 3 steps on your route. As mentioned earlier, there were many versions of Enigma, and the first ones, A then B, used only 3 rotors without reflector. These versions were produced till 1930. But that was in the military, as civilian and industrial version of this had input-output disks with different pairs. For example, A to Q, while the military used I/O disks with straight connections, A to A. Another difference for faster usage was the rings of rotors. For civilian use we had numbers from 1 to 26. Military ones had letters. With the introduction of version C, we got a reflector and a plugboard. However, this version had alphabetical keyboard layout and used 29-letter rotors with German diacritical umlauts, 28 pairs, 1 straight connection. This version was adopted by the broad military in 1930. However, Kriegsmarine later changed it to just 26 letters and QWERTZ keyboard, which became the M3 version. The M4 version, as mentioned before, has a 4/4 rotor, but due to technical constraints for the field usage, it never advances automatically. Let us check the longest strip that signal can go through. We will use Apollo machine M4 setting. 4 rotors. First is on the right side, first left position from I/O disk. First will be version 2, second version 5, third version 3, 4 version beta. Rotor 1 start position is Z, others A. Reflector will be CM4, and plugboard pairs S to G, N to C, P to O, LD, WB, AU. We press A. The first rotor advances 1 step forward from Z to A. Military I/O disks have straight one-to-one connections, so you can skip this step. But it will be mentioned here anyway. Input from keyboard A. Signal A hits plugboard A to U. Input-output disks. Through them, output U. Rotor 1, U to P. Rotor 2, P to X. Rotor 3, X to S. Rotor 4, beta, S to K. Reflector CM4, K to H. Rotor 4, H to X. Rotor 3, X to K. Now you might be a little lost, as we already have X to S on rotor 3, but the reflector bounces the signal backwards, so it is reaching the pair KX from the reflector disk perspective. Now we continue with rotor 2, K to Z, Z then rotor 1, Z to S, through the input-output disks as S, and the signal hits the plugboard again, S to G. The output is G with 11 scrambles. If you press A again, you will get another 9 to 11 scrambles, but with a totally different outcome than G. The first rotor advanced 1 step further, so connection points were also shifted, and the I/O connector of U is now pointing at the connector of the VY pair. Now there is another thing. The notch on the numeric letter ring. Enigma has 3 mechanical fingers on the back that pushes the rotors forward 1 step each key press. The first finger is thin and interfaces with the driving gear easily. The second and third finger are wider and therefore blocked by the ring. In order to advance the second and third rotor, they have to be aligned with the notch to have interface space for pushing them. Interesting fact: while base rotor versions 1 to 3 have only 1 notch, versions 4 to 8 could have 1, 2, or even 3. Another thing: is the daily ring setting, which moves a letter to prime position. However, it is only to control when the notch will interface with the finger. Such complex scrambling was one of the main reasons why the linguistic method of deciphering failed. It's because in such methodology we are comparing only the input and output texts, disregarding possible encryption methods in search for the key. The linguistic method works best only when there is a visible shift between input and output, either in text or in meanings of the words. Example: normal language versus specialist jargon. There is a build going on nearby. You see the crane lifting supplies to higher floors. The specialists see closed transport device which operator delivers required inventory to builders on the correct level of the build according to their plan. Now, if Enigma Machine rotors do not advance at all, hence we will get the same output letter each time, for today's settings, the linguistic method could work. But even then, the codebook with keys could be a massive one for each of the connectors, and each human error would require redoing the whole process of deciphering all over again. Have a look on the simpler ChatGPT example on the slide. You have texts encrypted 4 times by the Caesar code, shifting letters a few steps, A equals D, B equals E, etc. The left image shows how things would go when all 4 rotors are in the same position. You can write down which letter equals each. However, on the right image, you have a totally different outcome due to rotors being in different positions. So you have to catalog 26 to the power of 4, 456,976 possibilities if you compare input and output only, and that would be one big book to work with. And each time you will have to go through all of them to find the right one. What is worse, that number is just a signal path for a straight connector of 4 rotors, without reflector, disk, and plugboard. And backward route, which all multiplied would give a total of over 500 quintillion possibilities. For example, to compare, M3 complexity almost 150, which uses only 3 rotors, was almost 159 quintillion possibilities. The example starting word is not a bunch of letters. I will address that on the end of the presentation. Let's meet our 3 musketeers of math that broke the code. First is Marian Rejewski. Was born on 16th August 1905 in Bydgoszcz, in Prussian partition of Poland. He died on 13 February 1918 in Warsaw, Communist Warsaw, People Republic of Poland. All of them completed the same cryptanalysis course prepared by Cipher Bureau of 2nd Department of General Staff of the Polish Army in Poznan. Before their diplomas at Poznan University, and became part of Cipher Bureau in HQ in Warsaw in summer 1942. Rejewski invented the cyclometer and cryptographic bomb, the predecessor of Alan Turing's bomb. They were evacuated in 1949, Cadix team member, served as Polish soldier in England till 1946, then came back to Poland. Our second musketeer was Jerzy Różycki. Born on 24th July 1909 in Olszana, Russian Empire partition, died 9th January 1942 during SS La Mauritière catastrophe, where only 96 of 400 people on board survived. He invented the clock method for finding which rotor is the first to find quicker the characteristic cards from the cyclometer catalog. Also evacuated in 1949 and a Cadix team member. Last but not least, Henryk Zygalski. Born 15th July 1908 in Poznań, died 30th August 1978 during the visit in Lys. His invention were perforated sheets of paper, a catalogue of possible permutations for recalculation of cyclometer characteristic cards. Like others also evacuated in 1949, served as Polish soldiers in England and remained there. He had to redo math studies in England. Lived in Chichester. The breakthrough. Around 1927, cipher bureaus in countries around Germany already knew there is new encryption device, but the code was unbreakable for them due to lack of pictures of the device, instructions, code books, and already failed linguistic methodology. Finally, French intelligence agent Asher was able to deliver this in December of 1941. Unfortunately for most countries, this information were useless, as they still wanted to use linguistic methodology. Fortunately, Polish intelligence was eager to find any solution, therefore applying mathematical approaches too. Mathematical approach allowed our cipher bureau to manually decipher the code in December 1932. However, we need to reconstruct the machine before we can decode daily mode messages. Based on that, all mathematicians created the GREAT method, which resulted with relatively fast decoding process of about a day in 1944. It was a pure math with use of cyclic permutations calculus and assumption that only 6 of 13 pairs on blackboard were connected. At that time, the German military used mainly the B and C versions of Enigma, and the setting changed once per quarter or once per week until October 1946. To speed up the process, Cipher Bureau built Rejewski cyclometer, and our mathematicians created characteristic cards catalog in 1935. But how does that cyclometer machine work? Here is a quick instruction. Load 2 sets of 3 rotors while the second one is 3 steps ahead. Apply power to the device, then switch on any letter. Check if there are any other bulbs for other letters shining. If not, move the rheostat handle to the lowest resistance. Then count the amount of bulbs shining and divide by 2. Reset rheostat, then switch to off the current letter. Switch on any letter that was off during the first cycle. Repeat till you have all permutations catalogued. The invention unfortunately did not survive the war, but fortunately one of the British engineers from Cambridge University, Hal Evans, made a functional replica. You can see it on YouTube. Or you can click on the example on the table, which will show you the process. The true encryption battle began in 1936, when changes to the encryption procedures got introduced by the German military. Weekly changes of rotor positions were changed to each day. Kriegsmarine adopted the M3 version with new 3 of 5 set of possible rotors. Thanks to the characteristic cards catalog, after these changes, we were able to decode about 75% of messages. Our team estimated even 90%, if there were more people involved. Daily code finding time was still around 20 to 30 minutes. But to speed up the process further, Jerzy Różycki made the clock method, based on a linguistic approach. Due to the fact that the first rotor is always rotating with each key press, it drives most of the circuit changes. As we have more rotors in the set, we need to know which of them is in that particular position. We have to compare two German texts from the same day, even if these were already encoded with the device. That would be the weather report and general orders. Important thing, all messages for a day are encoded with the same starting position of rotors. If we put them in two rows and then we start moving them along, some of the letters will match. If the percentage of that is at least 10%, the assumed rotor is in first position. If not, we take another one. Now, bit of quiz. Why rotor rotation times could be variable? Please enter answer in local chat. The next change came in 1947. Reflector type B was changed to two-state reflector C. Technically, it was the same disk, but with alternated wiring on the other side. Enigma operators can just swap the sides to get version B or version C of the circuit before sending messages. That slight change made our entire existing catalog incomplete, and we had to redo the calculations of the cyclometer for the new reflector. To prevent mistakes in recalculations, Henryk Zygalski made his sheets, large paper sheets with perforated matrices, 4 per sheet. Unfortunately, 1938 came with two significant changes. The first one was a change of rotor positioning for each message. The daily setting of which rotors to use and on which spot in the casing they should be put stays. However, the start positions are now shuffled and not being resetted after each message. It made the previous methods obsolete. But thanks to Zygalski sheets, we discovered that about 40% of messages have pairs of the same letter in headings. These had 6 letters, used to set the machine on the other side with daily code. The pair happens on positions 1 and 4, 2 and 5, and 3 and 6. That allowed us to create the cryptanalysis bomb or cryptographic bomb, as some call it. It was the predecessor of Alan Turing's bomb and was a set of 3 cyclometers working at the same time, pushed forward by an electric motor. One such machine could go through all the rotors' position in about 2 hours. Each cyclometer in the bomb has output of 26 light bulbs. During operation, each cyclometer shows a different output letter. Figure 4a left. When a solution of the rotor setting is found, all three columns display the same letter. Figure 4b right. Until the end of 1948, we had 6 of these in the Decipher Bureau. Unfortunately, at the end of 1948 came the second significant change. Introduction of M4. Now, to get through all possible rotor settings, we would need at least 60 bombs working simultaneously. But the cost of production exceeds 15 times the budget of the Decipher Bureau. On 26 July 1939, just a month before the Nazi Germany invasion, Polish intelligence met their equivalents on France and England in a town near Warsaw. All the data we gathered so far was given to them. They were in shock that we managed to break the unbreakable. Alan Turing came to France, where he took the blueprints for our bombs in order to make his attempt in Bletchley Park. On the first days of the war, our cryptanalysis team got evacuated. First to Romania, then to France, as England denied help, then again to Algeria when Germany attacked France. Before Germany attacked on France, a French-Polish-Spanish cryptanalysis team was established and made the PC Bruno department near Paris. With more bombs, they were able to break the code again. They were sending decoded messages to Bletchley Park, but encoded again with always the same ending phrase. Unfortunately for the team, in May 1940, the German military made a final adjustment to send daily code only once per day. This made our bombs obsolete. In June 1940, our team got evacuated to Algeria. After France surrendered and got Vichy government, they were able to come back, however, with changed personalities. They created another cryptanalysis department called CADEX, which was used till summer of 1942. They were doing the same things as in PC Bruno. CADEX has a branch office in Algeria, so some of the cryptanalysis team had to constantly travel between those using public ships. Unfortunately, Jerzy Różycki died in catastrophe of SS La Mauritière near Balearic Islands during one of such trips. Our remaining team had to be evacuated once again, now with success to England as Polish soldiers. Now let's talk about truth in movies. The Enigma. Enigma does not mention the Polish part of breaking the code, as it was more a melodrama than documentary. However, there is a scene of decoding a message where added up letters are not recognizable for English-speaker words. It was recognized by Polish staff member as Polish names. That is 1941. The Nazi Germany is attacking Soviet Russia and finds out about the Katyn massacre, where NKVD, USSR Secret Services, killed over 22,000 Polish citizens in the forest nearby Smolensk. Not all of them were soldiers, around 15,000, but also teachers, engineers, etc., around 7,000, killed just because they wore Polish Army coats. They were deported in cattle cars from Poland after Soviet-Russia attack on Poland on 17 September 1939 due to Ribbentrop-Molotov Pact. Then they were killed by shooting the back of the skull in spring 1940. There will be 86th anniversary of that mass murder on 14th April. So tomorrow. The Polish government in exile in London demanded information from Joseph Stalin about that through the International Red Cross. Stalin cut the diplomatic relationships with the Polish government instead. The truth in the imitation game. Candidates see Enigma Machine, a gift from Polish intelligence. That Enigma Machine was supplied by a Polish agent who managed to get the Kriegsmarine M4 model, acting as U-boat officer. He literally took the machine just a few hours before the true officer. Another scene, candidates were told about the bomb. Same message with the same key every day. Most probably the teletype message from PC Bruno or Cadix, encoded with same ending phrase of Ha Hitler. This was meant to speed up the process, but also to not get suspicions from German officers. Despite what we've done, England turned back on our team, which was about 20 people, including original code breakers. In 1949, when they denied entry as civilians. In 1942, allowed entry only as soldiers. As part of the bloody foreigners, the High Command moved them to other things, to keep the secret. They were ordered to keep their mouths shut until the end of their military service, or even till retirement. Like for Zygalski, their diplomas after the end of the war were not recognized by the English government. After the Yalta Conference, where Stalin got Poland and Eastern Germany, they were not allowed to be part of the Win Parade in 1945, like other Polish troops, to not anger Stalin. First recognition came in 1973, when Polish correspondents learned about the diaries of Marian Rejewski. However, it was not spread widely due to the communism period in Poland. The heroism of our people during war and the Katyn massacre were taboo topics until 1991. We understand the decisions because of the circumstances, however we might not like them. Because we do not beg for freedom. We fight for it. As said General Witold Urbanowicz, 303, Royal Air Force, Polish Squadron Commander. Thank you. This presentation was based on research done for Poland History House exhibition, where you can find more detailed biographies, enemy cracking history with embedded videos and functional examples. The exhibition is available at Poland History House rooftop Cinerazer Enigma Code. List of my sources, both Wikipedia, both English and Polish, Polish radio archives, Bletchley Park videos, documentaries about Enigma on YouTube, Foundation National Pantheon, portal JE.pl, MacReader History of Mathematics Archive. You can contact me at this. And now, time for questions and answers. And first I will answer for Duga. Duga is Soviet over-horizon radar, installed nearby the Chernobyl power plant, also called Moscow Eye or Russian Woodpecker, due to the sound it produced. Please write your questions, I'll answer them on voice. Yes, many of the Enigma machines survived to present day, because Enigma was not only used by German military, but it was also an export good. So it was used also by Argentina, by Japan, other forces. Also there are some civilian ones available in the museums, and some even were in private collections. There's a few. What is worth to mention that there is an Enigma in also in Polish museums, Polish war museums, but there's also a currently special cryptologic museum in Poznań. So you can visit Poland and also get a glimpse, better information of cracking Enigma there. Yes, as I said, Enigma was also an export good in before the war, so Enigmas were sold to some Japanese military forces. Did the breaking the Enigma machine lay the groundwork for crypto analysis today and encryption today? I may say yes, because it was the first electromechanical device that uses a fully new code. Yes, much more encryption is done now with mathematics than linguistics. And now we will have also the computers that can do much more encryptions than current. Now, if you don't have any more questions, there's a thing I've planned for you, which will be challenge your mind. You can try and encrypt the phrase bloody foreigners with military versions of Enigma A, M3 or M4. The code is simplified, as rotor order is the same as in the real Enigma. Rotor's starting position is always A. Rotors do not advance at all, so you may get the same output letter. In the blue box under the table, you will find the detailed instructions note card. And that is all for today. If you like to stay and chat afterwards, we can go to the cafe on the opposite side of this auditorium. That's all. Thank you very much.